Hello everyone, this is Dino Chris from Prehistoric Facts. This is Prehistoric Facts special episode number 134, and we're going to do a marine animal today, and it's a type of fish, and that type of prehistoric fish is Xiphactinus. And so you can see this image here. This is from the Sea Monsters uh, movie that was from National Geographic. So you actually get the idea of how nasty this thing looks. It's a very nasty looking fish. Some information about Xiphactinus. The name means sword ray. Kind of think of it as not really a ray. It's actually a type of boned fish. And its length is 15 to 20 feet long, so 4.5 to 6 meters. Weighed 500 to 1,000 pounds. Lived 90 to 66 billion years ago in the late Cretaceous period. Found in Australia, Europe, and North America, and was first discovered and described by Joseph Leidy in 1870. So the first American paleontologist actually found the first remains of Xiphactinus, and Xiphactinus is mostly common in North America. So here's some images here. So on the left here, you got the map of North America. So Xiphactinus was actually found in states like, say, South Dakota, North Dakota, Wyoming, Nebraska, Kansas, Colorado, Oklahoma, those types of places. And you also see here is the skeleton of Xiphactinus. And if you look really closely, you can actually see another fish inside its ribs. Now this is kind of not too uncommon to see fossils like this, where you actually have a predator actually having its prey inside its stomach cavity. And so this Xiphactinus died very shortly after it swallowed a 6-foot long fish. And this is a pretty significant find, and it's a pretty cool find, I should say. And then you got the size chart down here on the bottom right is size chart compared of a human being swimming in the ocean, and you can see here Xiphactinus is a pretty large fish, and so I would not be in the dark areas of the ocean in the late Cretaceous period in the Western Interior Seaway with this thing roaming around. But there's other things that would scare me in late Cretaceous seaways. And some more information. Xiphactinus has got a bulldog-like head. You can definitely tell it's got needle-sharp teeth. It has a very distinct underbite, and I like to consider Xiphactinus as more like a barracuda with an underbite. Barracuda would actually be the best description of Xiphactinus. It's just that the Xiphactinus is probably not as sleek as a barracuda, but it will definitely be something that would actually definitely spoil your day if you're actually swimming in the Western Interior Seaway of the late Cretaceous. And it also, of course, Xiphactinus would actually be traveling in groups. So these are kind of like pack hunting animals. It's just that they never hunted cooperatively. They actually just looked for groups of fish that they could actually find, and individual Xiphactinus would just eat one fish into their cavity and take it and just swallow it whole. Because Xiphactinus did not chew their food; they actually swallowed it whole, because their teeth are cone-shaped, needle-sharp, designed to grab and hang on to prey, not to shred it like some other things like in the ocean, like sharks. And so the environment of Xiphactinus would be very warm, subtropical. There would be a lot of corals in the oceans, of course. Corals are very common. And of course, you would actually also have a bunch of fish, like sharks, rays, all those sorts of things. Squids, like your ammonites and your belemnites. Pterosaurs would be very common to be flying around there. Even as Xiphactinus could try to take down a very small pterosaur. Flightless birds were actually swimming around in the ocean, in the seaways as well, like Hesperornis. Hesperornis would be very common to actually find in the Western Interior Seaway. And there would be other marine reptiles, and some of those marine reptiles would actually eat Xiphactinus. So the predators and prey of Xiphactinus. So we'll start with the prey. Prey species that would, or the prey animals that Xiphactinus would actually be going after is smaller fish. It would actually also scavenge too. And on that skeleton that you saw before in an earlier slide, showed actually had a 6-foot long fish in its stomach cavity. And then you actually have the predators. So mosasaurs, giant mosasaurs would actually eat Xiphactinus, like Tylosaurus and some other types of species of mosasaurs. Cratoxorhina would actually eat Xiphactinus, and of course Cratoxorhina is also known as the Ginsu shark, and those guys would actually definitely eat Xiphactinus. And there's another shark in the late Cretaceous that would actually be eating Xiphactinus, and that'll be Squalocorax, or the crow shark. And those guys were pretty nasty. All those predators would be very nasty. So here's some images of the predators of Xiphactinus. So top one, the big picture, is Tylosaurus. Tylosaurus would actually definitely eat Xiphactinus because it's large enough to actually swallow Xiphactinus whole. And then you actually have on the bottom left, right here, is Cratoxorhina. It almost looks like a great white shark, but the teeth are very different from great white sharks. And then Cratoxorhina would actually be as big or a little bit bigger than a great white shark. And then you have Squalocorax on the bottom right here. It's not going to be as big as Cratoxorhina, but it would actually be close to 15 feet long, and it would actually be actually just shredding its prey like crazy. And these animals, their teeth are triangular shaped. They had serrations. They're kind of short teeth. If you actually look at their fossilized teeth, crow shark teeth are kind of small, and they do have serrations, which is really, really cool to look at. Cratoxorhina and Squalocorax teeth, but both sharks have serrations on their teeth. Not a mosasaur. A mosasaur has no serrations in its teeth. Now the extinction of Xiphactinus. Climate change would actually be a factor, but also at the end of the Cretaceous period, 66 million years ago, the giant asteroid that hit the Gulf of Mexico at that time came down and actually made numerous amount of events that actually caused a lot of extinctions. And so anything larger than 10 feet would die out. And so anything in the ocean that was larger than 10 feet would die out really quickly. But of course, you had a lot of sharks, you had some squids, and other types of fish, rays, all those sorts of things surviving the KPG extinction. And other types of fish took over, and so mostly sharks would actually be taking over the niche that Xiphactinus actually occupied. And then, of course, with the climate change, the seaways were retreating, especially the western interior seaway. It would actually be drying up. It would be retreating because the Rocky Mountains were forming in North America around 70 million years ago. And so when you have mountain building inland where there's a sea, that seaway is going to disappear because the elevation, the rising elevation of those mountains would definitely start showing some more dry land in North America. But other places like Australia and Europe, some of those seaways were starting to dry up as well, and so that's why you actually have a lot of those climate changing effects. But most of the asteroid impact that caused all those numerous events would actually kill off the rest of the Xiphactinus. So here's the map of North America, and so here is the Western Interior Seaway, and you can see where anything there's water in the middle of North America, you would definitely find Xiphactinus fossils, and so you will actually find a lot of them. And so this is what North America looked like, and then once the Rocky Mountains were forming right around here in Montana, Wyoming, Colorado, and New Mexico, those kinds of mountains actually helped retreat the Western Interior Seaway. Now the next episode would actually be on June 7th, 2019. It would be a Q&A episode. And so if you got any questions about dinosaurs or any other prehistoric life, feel free to email me at dinocris71@gmail.com, or just go on my Facebook page, Prehistoric Facts with Dino Chris. Like the page, you get your post your questions in the comment section or on the wall. But remember, keep your questions short to the point. You can also follow me on Twitter at CSGRALL. That's my Twitter page. I post pretty cool stuff on there. Also, take care of the people around you, and also for your younger people out there, to make sure to listen to your parents, your teachers, and your guardians. It's the best motivation you could have for good education. For a good education, it's very important to have good education. With a good education, you get a good job in the future. That's it for now, and I'll see you guys next time.